Chapter 15 and Chapter 16 are very closely related. They go together. Chapter 15 is about relationships or associations or correlations between variables, between things we're interested in. And Chapter 16 is all about how we're able to predict what will happen to one variable from what we know about another based on a correlation or association. One of the reasons correlations are studied, because if we know two things are related, then that relationship should allow us to make predictions. If we know that taxes and the gross national product are related, then depending on the level of taxation, we should be able to make predictions about gross national products. So the nice thing about correlations is that they will allow us to predict. Chapter 15 is about how we determine if two variables are correlated, and Chapter 16 is about how we make predictions of one variable from another. So let's look at correlations. Correlation is a statistical method, and we're describing the relationship between two variables. Typically, these are called an X variable and a Y variable. They can be variables related to people, personality, and self-esteem, cognitive ability, and grade point average. Or they can be variables related to economies, the relationship between the number of jobs and the extent of taxation, or regulations and jobs. They can be between nations, the relationship between the unemployment in a nation and the age with which people retire. We would study a group of nations to find out that relationship. But it's always between two variables that we're interested in, and it is a group statistic. In other words, correlations are found out because we study groups. Correlation is not an individual statistic. We don't base a correlation on just determining if there's a relationship between two variables with one person. We use a group. The key here is, in this bullet, is that a relationship exists when one variable tends to be accompanied by a consistent and predictable change in the other variable. So we're looking for relationships that are consistent and that they are predictable, and there's a number that we'll find called the correlation coefficient, which will tell us whether the relationship is consistent and predictable. Consistent meaning that these two variables are related in different groups, in different characteristics of these groups, and it's a predictable change. If we have information on one variable for a group, we can make a consistent and fairly accurate prediction about another variable. This is an example of a graph of a correlation. Each of these points represents two scores for one person. This point here represents someone's score on how long it took to complete an exam. It took this person about 31 minutes. And the grade that this person got on the exam. Looks like he got about a 62. This person here took about 50 minutes to complete the exam, and this person's grade was about a 92 or 93. Here we have someone who took 70 minutes to complete the exam and got a grade of around 48, 49. And what we're interested in is there a relationship between how long it takes you to complete an exam and the grade you got? And for the most part, the longer it is taking you to complete the exam, the lower is your grade. People who are taking 70 minutes, this these pair of people here are getting grades of around 62, 63. On the other hand, a group of people here who are completing the exam in somewhere around 30 minutes are getting grades of 85. Now, so there are people who don't fit that pattern. Here we have someone who took 60 minutes, 60 plus minutes to complete the exam, but who got a grade of above 90. So there are exceptions, but for the most part, we have a fairly consistent, predictable relationship between how long it takes you to complete an exam and the grade that you get. So we have a group of people, and we took two measurements on them. One measurement, time to complete the exam, our X variable. Another measurement, their grade, our Y variable. This would be another example of the relationship between family income, and we can say this is our X variable, and the student's grade average, our Y variable. Is there a relationship between the amount of money that a student's family makes and the student's grade point average? So we could find a sample of students, ask them what was their family income, and then also inquire what's their average grade in a particular area, or it could be their average grade point average. And for this group of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 students, we can see that there is a consistent positive relationship between income and grades. As income goes up, grades also go up. So here we have someone whose family is earning $170,000 and whose grade on a particular test was in the high 90s. Here is someone whose family is earning $30,000 and whose grade is 74 or 75. So we see a positive relationship, for the most part, between income and grades. And so if we knew someone's income, we would be able to predict their grades. Now, we're not saying that income causes grades. That's the important thing to remember. We're just saying that there is a relationship. There is a variety of reasons why income and students' grades are related. It could be due to a number of factors, but income is related to it in some way. The correlation coefficient is a number, and that number tells you three things about the relationship. It tells you something about the direction, whether the direction is negative or positive. We'll show examples of this in a minute. You saw two previous examples. The form of the relationship, whether the form is a straight line or a curved line, and the degree of the relationship. And we're talking here about the strength. Relationships can be strong, they can be moderate, they can be weak, and the number, the correlation coefficient that you calculate, will indicate the degree of that relationship. So the correlation coefficient, once you calculate it, will be a number. It'll be a number on a ratio scale. And we'll go through that scale in a minute. But that number is going to have a sign. If the sign is positive, then let's say, for example, positive 0.9, then that means that there is a positive relationship between the two variables. If the sign is negative, for example, negative 0.4, that means there tends to be a moderate, consistent negative relationship. Let's look at examples. If you have a positive correlation, the variables that you measured for a group of people, the two variables that you measured for one group, tend to move in the same direction. For example, cognitive ability and grades. As your cognitive ability goes up, your grades should go up. As your cognitive ability goes down, grades should go down. Self-esteem and job success. For a group of people, as self-esteem improves, the amount of success that they have in a job should improve. As self-esteem goes down, job success is very likely to go down. Time spent studying and grades. Here we have two variables. How much time do you spend studying, and what are your grades? The more time you spend studying, the higher your grade should be. The less time you spend studying, the lower your grades will be. Sales and profits. For companies, if we had we studied 100 Fortune 500 companies. For each company, we asked them what were their sales and what were their profits. The more sales, the more profits the company should make. The fewer the sales, the lower should be the profits. So the variables are moving in the same direction. Up goes with up, down goes with down. On the other hand, when we have a negative correlation, the variables move in the opposite direction. For example, if we had a group of people and we measured depression for every person, we would find that as depression increased, self-esteem would decrease. Conversely, as depression went down, self-esteem should go up. So the variables are moving in opposite directions. Let's take taxes and jobs. Now, if you're a Republican, then you believe that as taxes go up, job growth goes down. As taxes are reduced, job growth goes up. Another example would be taxes and the deficit. If you're a Democrat, as taxes go down, deficits go up. As taxes go up, deficits go down. How about hours of work and hours of study? The more you work, the less time you have to study. The less you work, the more time you have to study. The variables are moving in opposite directions. So that's what we mean then by direction, and that direction is indicated by the sign in front of the correlation coefficient. Here would be an example. We have temperature and beer sales. We have a positive relationship. As temperature goes up, the amount of beer sales goes up. Here we have a company, or in a particular situation, let's say where it could be a town, it could be a city, where we've measured for that town or city temperature, and we've measured the number of beer sales for that town or city. And so when the temperature here is 63, 64 degrees, we've got a fairly high number of beer sales. Well, if you look at the next graph, we have a negative relationship. What's the relationship between temperature and the amount of coffee sold? Things get hotter, we should have fewer cups of coffee. Well, let's look at this case right here. Here we have, for this particular example, this particular store, it could be Starbucks, on any given day, temperatures around 50 degrees are associated with coffee sales around 33 or 34. But as temperature gets very high, starts going up into the 80s, we have fewer coffee sales. So we have a negative relationship. And you'll see that pattern when you look at the dots. If the dots are sloping up to the right, here we have sloping up to the right, it's a positive relationship. If your pattern of dots is sloping down to the left, you have a negative relationship. We'll be studying linear relationships, meaning the form of the relationships is a straight line. we have a y variable, we have an x variable, and we're studying the form of the relationship. We want to know, is the relationship a straight line that extends or slopes from lower left to upper right, or is it a straight line that tends to slope from the upper left to the lower right? It could have, slope could be lower, slope could be greater, but the relationships that we'll be studying, the form will be a linear form, a straight line. The variables, the best model for the relationship is a straight line. There are nonlinear relationships. For example, you could have a relationship that looked like this. For low scores on one variable, we tend to get low scores on the other. As one variable increases, the scores on the other variable tend to increase. At some point, though, the relationship flattens out. So as we have moderate scores on the x variable, we tend to get almost no relationship, no change in the y variable. And then as the x variable gets higher, the scores on the y variable tend to get lower. So we start off with a positive relationship, we go to no relationship, and then we go to a negative relationship. This could be anxiety. At very low levels of anxiety, we have low levels of, let's say, learning. Let's say our y variable is learning, and our x variable is anxiety. At very low levels of anxiety, where you're really not that excited, you don't really care that much for what you're learning, you have low levels of learning. As your anxiety goes up, as you start caring more, your learning starts to go up. But at some point, there isn't a relationship, and at another point, when you have very high anxiety, your learning starts to go down. That's an inverted U relationship. We don't study relationships like that. You can measure that. There are correlations, correlation models, which we can study, called nonlinear relationships, but we won't be in this class. We'll just be studying correlations where the form is a straight line. Here we have two examples of nonlinear relationships. Your x variable for a group of people is age, and your y variable, you can't see it on the margins, but your y variable is reaction time, how quickly you react or respond to a stimulus. As you get older, what happens to your ability to react? Well, if we look at the pattern here, for people in this age range, as they get older, they tend to react faster. But as we age, at some point, we don't see that much of a change. And then, as our age goes up again, we tend to see increasing age with faster reaction times. And at some point, the relationship between age and reaction time flattens out, doesn't change at all. And at some point, it would even end with people who are in their 80s and 90s, that relationship would actually start to decrease. But we have a nonlinear relationship. It's not a nice straight line. If it were a straight line, then it would be the older you are, the slower is your reaction time. Or the increase in the older you are, it would take more amount of time to react to something. But that's not the case here. It's curvilinear. This example here is between dose of a drug and mood. At lower levels of the doses around 10, 20, we seem to see elevations in the mood of the drug. As the dosage level goes up, the mood tends to go up. So your line is sloping up to the right. and that relationship seems to hold. As dosage level increases, mood scores tend to increase, but at some point they flatten out, and changes in dosage level are not associated with any particular change in the mood. It's a relationship, it's a consistent relationship, it's a predictable relationship, but it's not a linear one. A linear one would look like this or look like that. When we look at correlations, the number tells us something about degree, and degree has to do with the strength. The correlation scale, it's a ratio scale. A 0 indicates no relationship. The highest possible relationship on this scale is plus 1.0, and the lowest possible relationship is minus 1.0. Positive relationships go to the right, they're all positive, plus sign, negative relationships in the opposite direction. And this is a continuous scale. We can have correlations of 0.1, 0.2, 0.3, 0.4, etc. Or we can have negative 0.1, negative 0.2, negative 0.9. The highest correlation, negative 0.1, negative 1, negative plus minus 1, and the highest correlation, plus 1. And we can have every number in between. This is a continuous scale. So between 0.1 and 0.2, we could have 0.11, 0.12, 0.13, 0.1462. It's a continuous scale. And as these numbers get higher, the strength of the relationship increases. We have a stronger relationship. As those numbers get lower, the strength of the relationships go down. The point to remember here also is that a correlation of negative 0.4 is just as strong as a correlation of positive 0.4, but they are in opposite directions. Here we have examples of scatter plots that show different degrees of relationship. Here we have a negative relationship. The variables go from upper right to lower left. It's a nice linear, straight line, perfect relationship, and that would be about negative 1.0. Here we have a strong positive relationship. The variables are going from lower left to upper right, but it's not a perfect relationship. This is a perfect relationship. This relationship would probably be positive 0.7. Here we have no relationship. There's no pattern. Typically when your scatter plots form a circle like this, we have a correlation of probably 0. R is the symbol, or maybe R equals plus 0.03. For all intents and purposes, that's a 0 correlation. Here there seems to be a slight negative correlation. The correlation here is probably negative 0.01, or I'm not sure, but it certainly is a weak relationship that doesn't seem to much of a pattern, but it seems that there might be a little bit of a upper left to lower right tendency. Your book gives you other examples of scatter plots to see if you can kind of speculate on what is the relationship when you look at the way the dots form. So when you're doing this study, you always need two scores. We have an X score and a Y score for each individual in a sample of people. So we have one group, one sample, two scores for each person in that group. When we're doing this type of study, the variables must be measured on an interval or a ratio scale. You can't do a Pearson correlation with nominal data or ordinal data. You can do correlations, you can do associations with nominal and ordinal data. We'll talk about how you do associations or relationships with nominal data when we talk about the chi-square statistic. When you have ordinal data, you can use a correlation called the Spearman correlation. But in this chapter, we're primarily focused on the Pearson correlation using interval or ratio data. And as it says here, other correlational methods exist for other scales of measurement. We'll be studying the chi-square, which is a measure of correlation for nominal data. And it's measuring the degree of linear relationship. Don't forget that. It's always with measuring the degree of a linear relationship. There can be a relationship between two variables, a very strong relationship, but it could be nonlinear, and the Pearson correlation won't tell us that. So we have two variables, x and y. As your chapter points out, we can compute a mean of x and a mean of y. We can compute a sums of squares for x and a sums of squares for y. We can compute a standard deviation or a variance for x and y. And computing a correlation involves all of these calculations. Our correlation formula, the numerator represents how these two variables vary together, or covariability. And your book uses the letters SP, sums of the products, for the covariability. And we divide the covariability by the separate variability. And the denominator for that is the sums of squares for y and the sums of squares for x. And we take the square root of that and we get our denominator. Your book goes through this formula. And so we're computing then the ratio between the sums of the products divided by the square root of the sums of squares for x times the sums of squares for y. So that correlation then represents the ratio between the amount of covariability, which is our numerator, the variability when the two variables, when we're looking at the variability of the relationship, and the denominator represents how those two variables vary separately. When we set up this ratio of covariability to separate variability, we will get a statistic called the correlation coefficient that will range from 0 to +1 and minus 1.0 and every number in between. And this number, as was shown, can be positive or negative depending on the direction of the relationship. Your book has a very interesting section on what affects the size of that correlation. It talks about the range of values. Here we have on our x, we have our variables, x variables going from low to high, and our y variables going from low to high. And here we have the full range of those variables. And when you look at the full range of those variables for the group that we're dealing with, you get a strong positive relationship. But if in your research your sampling strategy wasn't a very good one and you just sampled a small range of variables, here's the range of x for this group here, not very wide, and here's the range of y for this same group. Now we have what is called a restricted range, and you'll find that there is no correlation in this area. You can see the dots are all in a circle, where if we looked at all the variables, we would have a fairly strong correlation. The point is that when you're doing this type of research, make sure that the data that you collect represent a full range of scores for both variables rather than a restricted range.